Hi and welcome to the breadboard. In previous videos we've looked at the architecture of the PLCnext Control AXC F 2152 controller, and in particular the PLCnext Starter Kit, which you can see in this picture here. What I want to do today is look at the integration of the OPC unified architecture that is a standard feature within the runtime environment of the PLCnext. I'm not going to focus on really programming of the PLCnext, but more on how you can access, using OPC UA, the variables and I/O of the 2152 and its extension modules. So we have a 2 input, 2 output analog I/O module, and we also have the 8 digital input, 8 digital output digital I/O module that we can use. So it's not as straightforward as I initially thought. I'm fairly new to OPC UA. I'm very familiar with using Modbus and other protocols of the past, but I'm relatively new to this. So when I got a hold of the starter kit, one of the things I wanted to do was see if I can get this up and running and access it from Node-RED running, in my case, on a Raspberry Pi. But I mean, you could really host the client on any controller or PC or something that's able to run an OPC UA client. Node-RED happens to have a module that you can easily download and install, and it would show as a good example of where you would use a Linux-based gateway kind of product to integrate with some edge devices, in this case the PLCnext 2152, to gather statistics and maybe have some remote control capabilities without going to fully fledged Profinet or some other kind of architecture. The PLCnext has the OPC unified architecture built in, and all you have to do is basically configure a few key things and set up some variables. So we're going to go through how to do that in this video. I will not program anything complicated, so you should be able to replicate this very, very easily. I will mention some of the key things as we go along that I found as stumbling blocks. They took me a minute, and when I realized what they were, it was like, don't. It was pretty darn obvious. So let's get PCWorx up and running. Let's start a project. I'm going to start with an empty 2152. It has been upgraded to the latest version of the firmware, but that's all I've really done with it. There's nothing else special. It's exactly as wired with the starter kit. Now, in order to help with the demonstration, I'm going to connect a panel meter to the analog output so we can show the voltage being output on one of the DACs of the analog I/O module. As we'll set it up as a 0 to 10 volts. We'll also be utilizing the potentiometer that is part of the starter kit and some of the digital I/O switches, so that we can, basically have an understanding of accessing all of these different things. So just before we bring up PCWorx, here's a quick look at the OPC Foundation website, where they detail everything about OPC. They have some videos here as an introduction, everything else. But some of the key features: first of all, it was released in 2008, so it's a relatively new architecture. It is a collection of different services and frameworks, and it's a multi-layered approach. I'm just going to go through some of the key things here. It has platform independence. So they've now implemented it in a way, it used to be just sort of more of a Windows thing, and now it's completely open, so you can run it on pretty much any platform. It is secure. So one of the founding principles of OPC UA is you must be able to use encryption and authentication for the communications. It's extendable, but there are some requirements for minimal implementations on any platform that's going to be OPC certified. And it supports comprehensive information modeling. And again, a lot of the data types and everything else, the base set, are mandatory requirements for an implementation. Functional equivalence, we've got things like discovery, address spaces, on-demand reading and writing of data based on access permissions, subscriptions, and I'll show you actually how to subscribe to a data point in the example we're going to do in just a moment. Events, so alerts and things like that, and methods that you could also call. Now, I'm not going to get into methods and events here. I'm just going to show you the basics of getting to data points, so variables and things that are configured within the PLCnext controller, and we will subscribe to, for example, a few of the switch contacts for the digital I/O and the analog inputs or something like that, and we'll have some kind of controller on the Raspberry Pi that will allow us to vary those analog outputs. One of the things I want to say right off the bat before we get into the modeling as well is that for this to work properly, you must have set your date and time zone correctly, both on your client machine and on the PLC 2152. If you have them too far apart from each other, then you will get certificate errors and things won't work very well. And believe me, I bashed my head against the wall for a little while until I figured that out. And it's like, oh, of course, it's certificates. They're meant to be secure. They're meant to be able to trust the systems at each end. You don't have to be in the same time zone, but the time zones and things and the times have to be able to correlate. So if you're in GMT, if your machine is in the UK in GMT 0, and your client is in Canada in my case, and we are Eastern Standard Time, so 5 hours behind, you must make sure that when you take it to universal time, they are basically matched within a few seconds or so, or at least a minute. I'm not sure what the window is, but it's fairly tight, and it's easy enough to do. I just went in and set mine using the date commands under Linux, and everything was good. So that's the primary thing. Second thing is it is going to use secure usernames and passwords. I'm just going to use the admin default user in this case, but in a production environment you should create a separate user, and maybe if we have time in the video we can try that near the end and see if it still works and everything. I haven't tried it yet, so it'll be new for both of us. Alright, I've got PCWorx Engineer fired up here. What I'm going to do, and you'll find this when you load it up yourself, is I'm going to start with an empty AXC F 2152 project. So we're just going to open this up. So I'll take you through the beginning part of this will be the same whether you're using OPC UA, whether you're using C++, the IEC 61131-3 programming environments. It'll all be the same. So here is my test setup. Here's the PLCnext Technology Starter Kit. What I've also added to it, as I mentioned before, is a panel meter. This is a Lascar Electronics SGD28M fully programmable panel meter. You can actually program the graphics on this and everything else all under USB with free downloadable software. So I've got this configured just for a single input right now, and we're monitoring the analog output via this red wire that's snaking down here, and it's going to be programmed to use 0 to 10 volts. The temperature reading up here, that's what that is. It's measuring degrees centigrade. It's got an infrared sensor on the back of this module. It is from the RS Pro line. I'll provide links in the descriptions if anybody's interested in them. I did do a review on this a few videos back. As just monitoring the temperature of just the background. So basically it's just looking at the board, and it's feeding a 0 to 10 volts output into one of the analog input channels, and it's configured to output 0 to 10 volts representing 0 to 100 degrees centigrade. So that gives us two opportunities to monitor voltages, because we've got the temperature sensor and we've got the potentiometer here, and we've got one analog output going to the panel meter, so we can also attempt to set that up. And we've also got the 8 digital input switches, of course, which we should be able to read using OPC UA as well. So that's the scenario that we're going to program. Now let's go to the PCWorx and get started. Okay, so this is the first time I'm probably showing you on one of my videos how to set this up. But this is the opening project, what it looks like when you first start the PCWorx Engineer and you tell it you want to start using a template for the 2152 project. So you get the project folder and you get a placeholder for the AFX 2152, AXC F, sorry, 2152, and various other pieces. So here's our OPC UA link to configure that, and our axial line for the modules, and our PLCnext. Now the very first thing we really need to do with this is to configure the environment that we're working with. So for the project, we need to go in and we need to change the IP address, or in my case I do. If you're on a 192.168.0. something, then nothing for you to do. I'm on a .1.x IP subnet, so I'm just going to change this to my subnet, and then I'm going to go into online devices, and here is what it's expecting. It doesn't know my IP address of my device yet, so I'm going to tell it to search the network for devices. So that won't take it a moment. It should find my device, and there it has 192.168.1.10 standard device. Now you can go in and hand configure these things, but one of the easier things to do is just to right click in the bar and apply the online device settings to the project. If you change the project settings, you can send it the other way around. In my case, I'm going to bring it into the project. So I just click that and we're all okay. So now we have the AXC 2152-1 set up in the project with its network address and everything else. The next thing we need to do is add our I/O module. So we double click on the axial line, and you just click in where it says select type. So the first thing I've got is the digital input output, and it's a DIO8 D in 8 D out 8 1H. So it's like high-sided drive. So we pick that one, and we have the analog module. So we pick analog input output, and there's only one to choose from. So that's that, and that's the axial line modules now set up. So we can go back to PLCnext. We can see that by default with this template, we've got a main process all set up to run every 100 milliseconds. It will run this main instance, and under the PLC, we've got default data list, which is empty, and system variables. So system variables are reflective of the status of the controller, the tasks, things like that. We're not going to be looking at those, although those are available through the OPC UA. If we go into OPC UA right now and have a look here, we've got the basic settings. So here is our DNS name for the OPC UA. Input output port visibility. Right now it's set to all. I'm just going to leave it that way. If you, which means that any variable that's set for external access and all the I/O ports and everything else will all be visible to OPC UA. If you want to be very, very selective as to which ones you expose, which would be the normal case in a production environment, you would just click on marked and you would go and select them. And when we go in to look at the variables, you'll see, I'll show you where the checkboxes are that you can turn on and off the visibility if you're not using all. The security is set for self-signed certificates, and the Node-RED module for OPC UA comes with a self-signed certificate already for testing purposes, so we're just going to be using that. If not, you would have to give your client a certificate that it could use to communicate with the server. It's also going to use, of course, a username and password, and we've got discovery registration disabled. If you have that enabled, you'd have to tell it where you have a discovery server so that you could scan your network and find OPC UA services and things around your network. We're not using that, so we're just going to leave that disabled. When we go into the axial line, now that they're here, we can double click at these and look at our data list. So here's all our I/O for the digital, and here is our I/O for the analogs. Now, from a parameters perspective, like I mentioned to you, I do want to make sure everything is set up for 0 to 10 volts in and 0 to 10 volts out, because that's what we're using for our devices, and they are, so that's good. and that's the basic setup. Now we should be able to now also connect to the PLC by right-clicking on the 2152 and just say connect. It should prompt us for the username and password. So in this case I'm using the default credentials, so we have admin and the password that is on the front of the controller, and there we go. So now you can see the little shield here symbol, I think that's a shield, has now turned green, and the little run symbol is showing there as well. Now what that means, and by default I think it normally also goes into, there's a debug. It's not on right now because you haven't uploaded a program, but you can turn that on and off too to monitor I/O ports. So going back to the PLC link, when we double click this, we come back to our system variables and our default. This is where we need to start adding in some variables.